Hello and welcome to episode 4 of the Primary Maths Podcast, the show where we talk all things primary maths. I'm Jon Cripwell.
And I'm Becky Brown. Each week during term time, we'll bring you a brand new packed episode with classroom conversations, interviews with the experts, and ideas you can actually use wherever you're teaching.
We'll also be sharing a resource we think is worth your time and having a bit of a chat about the maths of life because, of course, maths is life.
In this episode, we're focusing on developing mathematical thinking through number talks and how this simple, structured approach can transform maths teaching across a whole school.
Yep, I'm joined by Omar Jennings, who is the head teacher of a high-performing school in one of the most deprived areas of the country. In this episode, we explore how number talks build fluency, reasoning and mathematical language from nursery to year 6, what it really takes to embed meaningful change in maths teaching over time, and how equity, clarity and a deep commitment to doing what works can reshape classroom culture.
Yeah, Omar is a brilliant guest and has loads of practical insights. As usual, we'll unpack some of the key takeaways afterwards, so make sure you stick around for that.
Before we jump into the maths of life, just a reminder that if you missed last week's episode, I had the pleasure of speaking to Amy Tinkler and Helen Bowen about the unique challenges and opportunities of teaching maths in small schools. They were brilliant guests with so much experience that they were more than happy to share with us. So if you haven't already, make sure you go back and give that one a listen.
Also, Jon, one final thing, but if you head over to Twinkle and search for the Primary Maths Podcast, you'll find a free PDF companion guide for this episode. It includes key takeaways from today's conversation, slide-ready summaries for CPD or staff briefings, some quick CPD video clips to use in staff meetings, and links to any resources that were mentioned in the episode.
And if there's anything else you'd like to see in those companion guides, or if you just want to say hello, don't forget that you can drop us an email at primarymathspodcast@twinkle.co.uk. We'd love to hear from you. So, Becky, today's maths of life from me is about nothing. Literally nothing. We're going to have a look at 0, which is the only number that manages to be completely empty and absolutely essential. Because 0 is weird. I don't know if you've thought about it, but it's properly weird.
Yeah, it's interesting you say, it's either nothing or it's really, really important. It is so important, isn't it, to understand that it is nothing.
Yep. And it breaks the rules of maths. It causes arguments, and your calculator will not forgive you if you try and divide by it. I was thinking about this last night because we've been having a look at a timeline, like a historical timeline, with my youngest daughter, and we were talking about the difference between AD and BC, and she asked me about the year 0. And did you know there isn't a year 0? It goes 1 BC to 1 AD. There's no year 0. And so, yeah, I was lying awake last night thinking about that, as you do for hours. And I thought, why wasn't there a 0? And it turns out there isn't a year 0 because it was the Romans that came up with the Gregorian calendar, and they didn't have a 0. They had no 0 in there. So for most of history, civilizations just kind of ignored the idea of 0. The Babylonians, if you remember those guys from the episode on time, they're back again. They used a space or a symbol to mark a missing value, but they didn't treat it as a number. The Greeks, they weren't keen on it either. They thought that nothing can't be something, so they didn't have anything. The Romans, we've already said, no 0. You'll know that if you've ever taught Roman numerals, which at the time of recording is still part of the curriculum, believe it or not. They were more interested in inventing the Colosseum and pizza and ice cream. I don't know if the Romans invented pizza, but it's definitely that kind of area. So it wasn't until the 5th century, would you believe, when Indian mathematicians finally decided that it might be handy to have something that actually means nothing. And they were the ones who wrote a circular symbol for 0 and then began treating it as a number in its own right. And they called it shunya, which I had to use Google translate to help me to pronounce. And that means void or empty. And then that word travelled from India, reached Islamic scholars, where it was translated into Arabic, Safir. And then when it got to Italy again, sort of back to the Romans, it became Zefiro and then zero. And from a mathematical point of view, one of the peculiar things, as I mentioned earlier, is that you can't use it as a divisor. It's not allowed. So it's the only number that you can't use as a divisor. Sorry. And people get very cross. Mathematicians get very cross if you try to divide things by zero, because generally, we like things to be neat and tidy in maths, don't we? But dividing by zero is undefined. It breaks everything. So we just pretend that it doesn't happen and we don't do it.
That's really interesting, Jon. I love the history of maths that comes through in your Maths of Life. Learn a little bit.
I was genuinely just a conversation that happened last night, and I just thought, well, yeah, where did that come from? You do have to be a little bit careful as well when you're teaching children about zero, because you can find yourself getting in trouble with some of them. I remember teaching working alongside a teacher, teaching a class in reception. So I'm not an EYFS specialist, but have spent some time working with EYFS teachers in my attempt to learn more about early maths, because I think it's really critical that maths leads understand what's happening in nursery and reception if they have those in their school. So I was working in a reception class, and I was trying to judge where the children's understanding of zero was. So I went, as always, back to the trusted resource of cakes. And I said, if Miss has got one cake and I take that cake away, what do we have left? And one little boy's arm shot straight up in the air. And I said, yep, what have we got left? And he said, you shouldn't take people's cakes. You can get in a lot of trouble for taking other people's cakes. And then he pointed at somebody else and he said that they had got their first warning for taking somebody's cake last week. So maths, PSHE, social skills, all intertwined there. And we've all had that situation in class where, I don't know, maybe you haven't. If you've not done this, do this in class tomorrow if you're a teacher. Go into class and ask them whether zero is an even number, and then watch what happens. You can have whole debates and arguments about this. There's probably a period of silence, and then, is zero an even number? It meets all the criteria of an even number, given that it's not odd, but also you can divide zero evenly, even though the answer will be zero. So you can't use it as a divisor, but you can divide it. You can have two groups of nothing, and that's fine. Yeah. So zero is an even number.
I knew it definitely wasn't odd.
Yeah, it's definitely not odd.
Really
it's between two other odd numbers, -1 and 1.
Yeah.
And it's even. So there you go. Next time you're thinking about nothing, you can understand that it's kind of everything. Everything would fall apart. Our number system would fall apart without it. So there you go.
Absolutely. Zero the hero.
What's been on your mind this week, Becky?
So nothing really to do with history for me, Jon, but I was surrounded with maths this week because I was lucky enough to spend my weekend at Alton Towers theme park.
Ooh, so excellent. That's one of my favourites.
There was, mine too. And there was, of course, there is maths everywhere at a theme park, as you can imagine. But we were very lucky. The weather was gorgeous, but that did mean that the queue times were slightly longer than the previous times we've been where it's been a bit rainy. So the app got a lot of use in telling us what the queue times were for each of the rides. And it was my eldest son, I think, who pointed out that they were all in multiples of 5, and how they got to that multiple of 5, whether it was rounded up or down, which then just made me think a little bit about rounding and how actually you can make rounding work in your favour, can't you? I don't know whether they were rounding in the traditional math sense and giving you the closest approximation by getting to the midpoint and then rounding up, or rounding down the other way, or whether they were just rounding up so that you'd get a nice surprise and it wasn't quite as long as you thought it was going to be in the queue, or if they were just truncating and removing everything else entirely and going to the previous multiple of 5. I mean, In this instance, it didn't really matter because it's not an exact science. I don't think the queue times on the app really reflected how long we're in the queue. But it got me to thinking about rounding and how actually in real life, when approximation happens, how much of it is rounding, how much is truncating, and how much is just manipulated to meet the situation. I don't know the answer, but it was just something we were thinking about this week.
Very nice. It reminds me of Douglas Adams, who was the late author of the Hitchhiker's Guide to the Galaxy. In those books, he has a concept called bistro maths, which means that whatever you think you're going to pay, if you go to a restaurant with a group of friends, whatever you think you're going to pay, you will inevitably end up paying more, and there'll still be a little bit left over at the end that nobody's claiming or taking account for. And, obviously that must be something to do with rounding as well.
Yeah.
But yeah, do you round up in your favour or do you round down?
So now it's time for this week's guest interview.
Today I'm joined by a head teacher, maths leader, NCETM mastery specialist and digital education advocate who brings together deep experience in classroom practice, system leadership and tech-enhanced pedagogy. With over 20 years in education across Canada, Scotland and England, he's driven by a commitment to equity, excellence and evidence-based teaching. He currently leads a high-performing primary school in one of the most deprived areas of the country with a relentless focus on equity and excellence. Whether it's through coaching staff, trialling adaptive technology with Impact Ed, or designing teacher workshops around number sense and algebraic thinking, he brings clarity, curiosity, and a relentless focus on what works. My guest today is Omar Jennings, and I'm delighted to have him on the show. Welcome, Omar.
Thank you. That's the best introduction I've ever had in my life.
Well, I aim to please, but it's all true. So we need to celebrate these things because that doesn't happen enough, I don't think, in education. To be honest, people are doing great work, and it needs highlighting. So listeners may have already picked up just from that brief response there that although you're based in London now, that's not a Cockney accent that I'm picking up. So if we could start with just how have you ended up where you are now, Omar?
Yeah, my journey started off actually in education within Scotland. That's where I went to university. I went to the University of Strathclyde. I did got a PGCE there, and then went back to Canada, taught there for 3 years, then came back to Scotland, taught for a couple more years, about 3, and then came down to London, and I've been here ever since. So the majority of my time has actually been spent teaching within the London area. But I think I've been afforded a very blessed experience by going to so many different places and experiencing so much diversity in terms of what teaching styles and expectations are. So if you look at the difference between Canada and the UK, at least within Ontario, the educational system is very prescriptive. They tell you what you're going to teach. They're going to give you the resources. They're going to give you all of the things that you need to be successful. Where when I remember first moving to London, I think they were still on the literacy hour and the math hour that was introduced by Blair and his government. So it was very different. You had some prescription, but you still had to figure out things yourself. And that's still something you have to do to this day. So it's definitely different.
How do you feel now about that sort of tension between prescribing exactly how to do something and what to do, and having that freedom to explore the best way to do things?
Yeah, I think there's been a bit of growth where the DFE is concerned in terms of actually giving credence to particular resources that are approved. And within those resources, you still have the flexibility, the autonomy you were mentioning to kind of do what you want. We were one of the early adopters of using Maths No Problem in about 2016 at the school. For us, we thought we knew how we were supposed to use it. And I still think we're trying to figure out aspects of that to this day. So whilst you have more resources that are DFE approved, you still have the autonomy to try to implement it the way that you want.
That's really interesting. And actually just talking about that journey with schemes of learning and things in your school, I think you've hit the nail on the head when you say that you're still working out the best way. I read a quote by James Clear this morning. He wrote a book called Atomic Habits, which is a great read for anybody that's trying to build consistency, I think. And he said that success shouldn't be measured as an end goal, but rather an ongoing process of refinement. And when I was reading that, I was thinking, yeah, that's teaching. That there isn't an end goal, is the way you sort of go, yeah, we've got it. It's always evolving and always changing. I always ask this, Omar, of all the guests. What was maths like for you at school? Obviously, you grew up in Canada. Did you enjoy maths at school, or was it a subject that you looked forward to?
Sort of sat in the middle, to be honest. I wasn't exceptionally passionate about it. I think I became passionate about it when I actually understood the science behind it, right? So it wasn't something that in school that I extremely enjoyed. I went on to be, I minored in economics, right? So I didn't mind math, but it wasn't something that lived me, if you will. What I definitely recognized was I'd been teaching math and really enjoyed it because I think it was, having a conversation with a colleague at a PedTech conference that was taking place at Amazon actually on a Thursday. One of the things that he said was this: maths is a universal language. And as a teacher in an area that's extremely deprived, our school sits between anywhere from 70 to 75% EAL. That's true EAL. That's, kids who aren't speaking English at home and only speak English when they're actually coming through our doors. That for us represents a need to be able to find something that allows them to see success. So it's something that I became really, really passionate about as I developed as a teacher. I was thinking about when I was back in the class as a full-time class teacher. I still teach, by the way. I still teach year 6. This is something I still do to this day. It's something I'm extremely passionate about. So, whilst I'm a school leader, I do feel like you need to be on the ground to actually implement change. Actually, going to the training with the NCTM, that was like my first foray into, well, this is what math is supposed to be like, and this is how you can do it really well. I had to walk away from my previous understanding, which I thought was good, and have a really good moment of reflection and saying, no, I'm starting from scratch. And that was almost 10 years into teaching. Right? So for me, it was humbling, but also one of the best things that's happened to me, because now I'm a massive advocate of math, particularly within our school, because it is the universal language for our families. It's definitely something that they can support with. While they're not able to keep up with certain other aspects, they can definitely support with math. So it's become our, if you will, our way of actually proving that, with just good systems and good approaches, you're going to be able to do well.
So much to unpick there, Omar. So much that I agree with as well. Before we go any further into that, it might be useful, because you've talked a lot about the school already, and I can see it is a real passion of yours. And I love the fact that you're still in the classroom as well, because so many head teachers, I think, understandably get pulled out of that. So I think it's a great way to lead by example, and also to, keep that passion for teaching.
One of the things that comes from it is, like I said, I prefaced earlier, we're really passionate about trying to get things right, knowing that we're never going to get them right. But we want to try to find a way to genuinely improve the quality of teaching and learning. So when I started developing an understanding of procedural variation, having a deep understanding of conceptual understanding when it comes to math, small steps, concrete, pictorial, abstract modeling, when I first was introduced to that, like I said, it was an epiphany moment of, wait a second, I have no idea that these things were so important. I can blame that on the rock star at the time, which was Yip Ben-Har, and going to quite a few of his conferences and realizing I had so much to learn. And I feel like I wanted to accelerate that whole process, which meant the school had to accelerate their process, because we wanted to make sure that we were giving them what would we recognized was much better teaching than we were traditionally doing, which was having really good systems in place, but not really understanding the pedagogy behind how to teach math effectively. So we made the mistake of not really understanding how to do the initial hook in their lesson approach. And for us, we recognized, okay, cool, this is a really great approach, but our kids aren't getting it, and it's too quick. So we went up to Three Bridges. This is where I get to celebrate one of another of our colleagues, which is Jeremy Hanna. I don't know if you've ever heard of Jeremy Hanna. He works at Three Bridges in Southall. And he was one of the first schools that I was able to visit and kind of transformed what I thought was possible within a school. It was the way that he actually prepared his anchor charts. It was everything was extremely, going back to our previous conversation, extremely consistent. And what he introduced was a pre-hook. So he was having a similar issue. They had to think about what they were going to ask the children to do within the lesson and give them a pre-question before the actual hook. So accessing their prior knowledge before they could actually go into it to see if they could even answer that hook question. Because we found that we were spending a lot of time on it and the kids weren't necessarily progressing into the lesson as best as we possibly could. So yeah, we fumbled through that for almost 4 months. And it was amazing to just sort of figure out that every element of that lesson, even if because we were we're massive proponents of using gradual release at the moment. But even at that earlier stage of trying to understand what the guided practice should look like before you push them off into their independent practice was completely different than how we would have been teaching math in the past. And it took us a year to realize, well, we actually need to teach fluency separately. Because we thought it was going to pick up all of those things. And this journey is going to take us quite a bit of time to unravel. We were really fortunate. Like I said, I've been leading math for quite some time up since that point, but just clearly not as well as I thought I was. And I had a really good system in place from John Mayer, who is also another colleague who was absolutely instrumental in my very early stages of trying to understand how to set up systems. And he gave me one that I still use, and within the trust we still use. We're part of the Maritime Trust that we still use to this day, which was just doing 4 questions, like four questions that they need to be able to answer by the end of the year for you to identify trends. So we were looking at an addition, multiplication, division, and a subtraction question that they should be able to do.
And this is separate to the main lesson, Omar, is that right?
Yeah, this was just a very simple, how do we assess what kids can and cannot do? And that was the epiphany moment for me as well, because I thought after that first year of using Maths No Problem, things were going to go great. This would be the solution to our problems, as you would with anything that you kind of put on the shelf, and we couldn't be further from the truth. So that's when we did this assessment the following year, and we realized, wait a second, it hasn't actually solved as many of the problems that we were hoping it would. But just using 4 questions was really powerful because we're going to be able to use a similar set of questions as we moved up every 3 terms. It was like the long terms, not half terms. And we were going to be able to use that assessment tool to make sure that we're making improvement in the way we wanted to see, particularly with the number sense, because I think through everything that I'd learned up until that point, number sense was the most important thing. You had to be numerate, and if you weren't, I can talk to you a little bit about the number talks and all the stuff that came in after, but we had to have that very clear. Are the strategies that we're putting into place working with just those 4 operations? And from there, you can kind of build your foundations. But until you get those right, you're in trouble. That's how we kind of.
I can agree with that. And so you had these 4 key questions that you would keep coming back to help you monitor progress and readiness for the next stage of learning. And then they have a hook which starts the lesson with a problem. Then they have guided practice and then some independent practice. And correct me if I'm wrong, Omar, but different schools use these things in different ways. But the guided practice is sort of the teacher's opportunity to check which children might need some further support, which ones are ready to move on to the independent practice. But you spent a lot of time working on the hook or the explore part of that lesson. And you were finding that children were not making as much progress in that session as you wanted, and that was because of potential gaps that may have been in understanding before getting to that point. Is that all correct? Is that sort of a summary?
That's 100% correct. I think what we were recognizing was that pre-hook to assess, would they be able to actually answer the question, or even to pre-teach, because it was used in both ways, to pre-teach what that explore activity was going to be, was necessary. So going to 3 visions, seeing it in practice, seeing, oh, okay, cool, that really will allow your lesson to sort of smoothly flow into the guided practice, really helped us a lot. And then there was lots of little things that we did to anchor alongside of it. So some schools were really heavy on the journaling aspect, looking at the actual textbook and using the textbook quite heavily. We sat between both sides of doing that. So there'd be activities where we would use a textbook and there's activities we wouldn't. There's usually at least, within the variation guided practice element, there's 3 things that you kind of were looking for in terms of a skill. So one was usually concrete, one was pictorial, and one was usually algorithmic, and that you wanted to follow one of the 3, and children could go down the routes that they wanted to. But we again recognized that led to an inefficiency problem. So after using it for a year, kids could choose a method, but they weren't necessarily pushing themselves to an efficient method. So the following year became a real job for us, where we were trying to think of what would be the language. We made it our always. So what is your always method, and what is your sometimes method, and what is your rarely used method? Just to make sure that you can kind of check where you were at with the children. And for us, that kind of helped us narrow down that, okay, we're always going to lean towards the algorithm. We're going to try to push the children to that, but we're going to make sure that they're exposed and understand the other elements. And that's where number talks became a massive part of our school.
And we'll definitely go on to talk about those in a moment, because I'm really interested in that. And actually, you shared a post on LinkedIn which prompted this conversation, actually, because I was really interested in how you were using those. But just before we move on, I think you touched on something else there that's really important, which is sometimes there is a misconception that we're teaching children lots of different methods to enable them to choose the one that they prefer. But that might not be, as you say, the most efficient method. And what we want is, I think, flexibility and adaptability in thinking. And that's why we expose them to these different ways of doing things, but understanding as well that there is probably for each situation a better way to answer the problem.
Yeah, and I think the one thing that I would add on to what you've said with regards to flexibility and adaptability is relationship. So we wanted them to understand the relationship of going from concrete to the algorithm and how they were interconnected, and that one was representing the other. So trying to teach them next to each other was one of the skills that I definitely found useful and learned working with the NCTM. We went, myself and our cohort, which was cohort 2 for the NCTM, went to Shanghai.
I'm jealous, Omar, because I missed out on that. It was COVID put a pay to that for me. So yeah,
an absolute halt on it. It did. Because I was hoping at some point I would have paid myself to go back another opportunity, because I learned so much within the 2 weeks that we were there. And in that time, I watched them model side by side, even if there was using the algorithm to do short multiplication, they would model the steps that were happening next to it on the right hand side using the expanded form. And for me, that was like, well, why wouldn't you do that? And I realized, again, going back to me teaching in my first 10 years, it's like I would have never done that at the point. I was just went over and over the same thing, gone slower. I wouldn't have actually taken that simple step to show them the expanded form and how they connect to each other, and make sure that there was some language associated with the steps. And all of that was there. And it was really beautiful to sort of see. So from that experience, I was able to get a better understanding of why number talks for us would be extremely important. When I went to Shanghai, it's a very different education environment in that it's homogeneous and it's not a heterogeneous work. So they're very focused on things that aren't necessarily an issue in our schools. Our schools, if you walk into most classes, there's going to be, particularly within primary, there's going to be kids who are really good at mental calculation, and there's going to be kids that aren't. The majority of the kids were good at mental calculation, so they could kind of go into the deeper thinking about mathematics instantly, and that was a massive difference. They had specialized teachers for mathematics in primary. That was a huge difference in comparison to what we were doing here. But some of those things that I picked up whilst I was there are still things we use to this day. Even again, if you go to what we try to do in our school in year 5 and year 6, we specialize the teaching. So there's only one teacher two teachers, it's myself and Miss Shukla, that teach math within that year and 5 year group, because we understand the beginning of what year 5 is, and we also know the end goal, and we want to make sure that they're as prepared as possible. And there's only one teacher for English. And then they have specialist teachers for computing and for PE and all those things that are going to allow them to transition into secondary more effective. So it's a really important element that I was able to take away and say, no, it makes a huge difference to do this. Not a slight difference, huge difference. It's like the looping effect that comes up in the book Hidden Potential by Adam Grant. Talks a lot about what they've done in certain countries where if you're taking your child all the way through, you no longer have to actually think about their needs. You can actually just get to their needs, as in their social and emotional needs. You can actually get to the heart of the actual learning quite quickly because you know them. So knowing them in 5 and knowing what their gaps are in 5 and how much they're going to need to improve for 6, you already knew that. So you don't have to do the heavy lifting again as a new year 6 teacher. So we have been doing that since 2021. So for us, it's been something that's an embedded approach at the school, and is one of the reasons that we consider ourselves a really good school in math because of, that's definitely one of them. It's such a difference maker.
But one thing that keeps coming up, and to listeners, I'm going to sound like a broken record on this, but it's just amazing because, again, unprompted, one thing that keeps coming up time and time again with everybody that I've spoken to, Omar, is just the importance of relationships in learning, and the importance that can be attributed to a teacher that really knows their pupils. So, and as you say, not just in terms of their formative assessment of learning, but the trust and empathy that goes along with that as well. Let's go back to number talks if we can. So for listeners who might not be familiar with the phrase number talks, would you mind just explaining what they are and then how you came to include them as an important part, I think, in your teaching approach?
In a nutshell, number talks is allowing people to articulate and justify mental strategies. Teachers would pose a simple string. Suppose you were looking at 18 plus 29 or 28 plus 29. And those are the only 2 questions that they actually face within the number talks. And the design behind that allows you to work slowly, make the connection, knowing that you're just making an additional 10 and see the number structures. But you're allowed to let children come up with a multitude of methods. And I think that's the beauty in it. What we also really like about how we've introduced it at the school is it was kind of a natural approach. Myself and Mr. Gardner, who was the year 6 teacher at the time, what we said was like, let's just try it with the year 6s and see how it goes. We got the book from Ruth Parker and Kathy Humphreys, Making Numbers Visible. Making Numbers Talks was the name of the book. And we just loved it. And we wanted to take it a step further the following year after we introduced it. It was so hilarious. Sorry, I have to give you an anecdote. The student who helped us realize this, a child who was in our school about 7 years ago, who helped us introduce the whole process and really gave us the confidence to use it, came back and was doing some teaching with our year 6s just before the SATs. So it was a full circle moment to have him go up and use algebra to help children answer a ratio problem question that they were getting ready for the SATs. It was a great moment for us because myself,
proud moment,
and the teacher were going, wow, I loved when he was here because he had a real massive passion for math, and it was something that you could tell that he was going to be good at. Because we'd introduced a bunch of other things that we can get into later that he took to, and we kind of changed our school because of it. But going back to it, it allows confidence, flexibility, and fluency. You have the space to try to come up with these multiple approaches, if you will, and to a particular question. And that's what we really like about it. So number talks then started to take a bit of an evolution. I'm going to give you an example. There's this book, and I'm a massive fan of this book because it's, as you can see, it's very thick. It costs about £100, so it's not cheap.
We'll put a link to it in the show notes if you're listening to this. It's just read the title again for me.
Yeah, number talks. It's called Number Talks, Fractions, Decimals, and Percentages. That took us. They had another book which is called Number Talks, which is Computation. It's by Sherry Parrish. And what in the book, it gives you that instructional step by step, which is what we needed because we knew we were starting this from scratch. I knew that the book that we initially got, which was by Ruth Parker and Kathy Humphreys, that was the concept of doing it. It didn't give you a guide. It didn't say this is what you should do with this year group. This book starts you right at the beginning where you're looking at subitizing, where you're just looking at dots, and you can apply that to children in nursery all the way up to year 6. And that's what we did. So we started everybody off doing just looking at a set of dots and asking them to identify what they were able to see mathematically. And what we, again, massive moment for us was such a low entry. Everybody had a way into the lesson. So there was nobody that was sort of being held back, and everybody can contribute. Now, within the post that I've shared with you, you can see that I've obviously taken the children's names out of it. That's the evolution of it. We initially went through this whole process where we were just recording the children's information upon the board. We didn't assign names. We've introduced possible guesses. Straight away, if kids think you've got a couple possible answers, we put possible solutions in a bubble off to the side. And then we go through the process of solving and identifying how children are thinking about it using both pictorial. Sometimes we're using deans as the way we're writing it up on the anchor charts. And that's the beauty in it, is that everybody kind of is given an opportunity to expose their mathematical thinking, and it's also appreciated, so that it became how we introduced our lessons. So number talks sort of sat on top of it, just to make sure that everybody could have an opportunity to be exposed to the language, the vocab, and just see that exposure around different concepts that are approaching different questions. And yeah, it's
so I'll try and share, if that's okay with you, Omar. I'll try and share the pictures that you shared on your post about this. But essentially, you're looking at a piece of A3 paper.
No, it's A1. It's actually
A1.
It's just an anchor chart, so it's just like a flip chart paper.
Flip chart paper, and the question or equation is in the center, and then around that, children are writing the different approaches that they might take to understand the structure of that, and also how they might solve or approach solving that question, and the different ways that they can see it. So as you said, pictorial representations, partitioning, algorithms, whatever that might be. And it's a group of children working on one piece.
No, it's one child. It can take multiple forms. Sometimes when we do word problems, what we want to do is get children to talk. So next year we're going to be doing some number talks without numbers, which is going to be the beauty in it. So we're going to be giving them word problems without the actual numbers, to get them to think about what the question is asking first, then insert the numbers, and then build on from there. That was given to me by one of my colleagues who works within the NCTM, Becky Hillary. She's amazing, and she introduced me to just the concept of questions without the numbers. And it was another penny drop. And I was like, yeah, I know exactly where I'm going to use that. I know how I'm going to use that as well. So
Gareth Metcalf's done a lot of work on that side of things, and well worth having a look at. And in my school, we did quite a lot of work with the anchor task, or the explore task, if you like, where we would cover over certain information. So we're getting away from the idea of, because sometimes, particularly when you're doing maths, you see a number and you jump at the number and you forget to look at everything else around it. So sometimes I think with problem solving, taking away that number and actually just thinking, what can you see? What do we know? What's the structure of the problem before you include some numbers is great. And even just taking away some of the superfluous information as well and adding that back in can be a way in. That worked really well for us. And as I say, Gareth Metcalf is definitely somebody to check out about that. In terms of the presentation and things, how worried are you about how children present on these, large pieces of paper? Are you asking just so that people can imagine it's not squared paper or anything? You've got some freedom here, haven't you?
Yeah, you've got freedom. And that kind of goes into, our math mastery approach, which I can come to later. But the teacher usually models everything that the child has actually said. So the teachers or our HILTAs will be up at the front. As the child is explaining their answer, they might say, I would use a number line, and here's how I would use the number line. And they explain the steps, and the teacher then models that example. And on the occasion, you'll actually have the child come up. So within our reception year group, the kids will come up and they'll actually identify what their thinking was on the board for them. They're the class, and I think I mentioned this, reception is the class that are using this far more than any others, because they're at the early stages of numbers. But if you walk into into reception, what you'll notice is they're they'll say add in and add in, and then they'll use subject end and menu end. They'll give you product. They'll try to use the language. Sometimes the understanding is there. Sometimes the understand, but it's the early exposure that we're searching for, and you can clearly see that that they are able to subitize quite confidently. They're able to actually use math in a way that we wouldn't have been using in the past if we didn't use number talks. So number talks then leads into her white rose activities, which then leads into some of the other activities that she set up at our tables. This is Miss Cody, who's our perception teacher. She's been fantastic in saying, as a person who, I don't think she'd mind me sharing this, as a person who's dyscalculia, she absolutely loves math now. Because she is like myself, where she's recognized it was understanding how to teach it. And she really wishes that she had that opportunity where somebody was able to expose to her the way that she's exposing math to her pupils. And I think that's the beauty in it, is that, we just didn't, I don't think we got these opportunities when I was young. So I kind of look at it differently, and I want to make sure that the kids have that kind of time and exposure, and which is what Number Talks provides.
I think what a fantastic way to get that vocabulary into children using it, not just it being modeled to them, but they actually have the opportunity to use it. And it's interesting that you talk about some of that very subject specific language being used by the youngest children in your school, which is great to hear. And sometimes there's a little bit of pushback from staff that are less familiar with that language themselves, that we're expecting quite young children to use unfamiliar language. But I'll normally push back with, well, if they can use digraph and trigraph and phonemes in phonics, then why not add ends and subtrahends and things in maths?
That's exactly
all language is new, right? All language is new until you hear it.
I love that. That's exactly where I was going to go with the conversation. If you can say split digraph and know what it means, then you should be able to use add in some. I mean, it's the least you can do.
And the purpose of it is not just to make it more complex, but it's actually to simplify it and, to give things a name, which helps you to talk about them, right?
Yeah. One of the key things that, Number Talks, when I explain this to people and I say, here's why the words matter, here's why the nouns, here's why they matter, try to get a child to explain 3 squared without using language. Right. And see how confusing that explanation is unless you're able to go to a factor and a factor without actually being clear, or multiplicand and multiplicand. If you can't use that language confidently, you're getting your child into a muddle. You're just going to say, use this digit, and you might not even say digit, you might say number and number. So we spent years peeling back what are the exact terms that you want to say when, because it's essential. And it's in those moments where you're having to explain to a child, well, how do you convert a mixed number into an improper fraction? You can't say I multiply this number by this and this number, and then I add this number. You actually need to be able to use the terms, and you need to be able to use them confidently. I'm taking the denominator, I'm multiplying it by the whole number, I'm adding the numerator. So that language where we would teach children, we are explicit about that. And I don't know if some schools are, but I definitely know that allows us to be very clear and support the children in their understanding.
Yeah, absolutely. And just for teachers to be able to talk about those things as well with the students, I found maths quite confusing at school, and I think that would be something that would have helped me quite a lot, because it gives a very clear label to the part of the maths that you're talking about, which is just very helpful. And what you would do in anything else, if we're talking in geography, we label up, volcanoes and their different parts. My knowledge of volcanoes is going to let me down here, but you go in some very technical language to help you understand how a volcano works. And I don't know why we've avoided that in maths for so long. But it's really interesting. So, Number Talks then, is this something that's used across Nightingale Primary now, or just in reception in Year 6?
No, we use it from nursery to Year 6.
Wow,
and
fantastic.
what we really do is make sure that it's kind of mastered within those 4 operations, and starting to move into reasoning and word problems from pretty much nursery to Year 5. In Year 6.
And is this, is this part of daily maths, or is it something we do
Yeah,
once a week? Or
minimum 2 times a week, but it's for some classes it's daily. It just dependent upon what that class needs and where they are in their journey, right? So we do give some autonomy to the nature of the class and how apt they are with with math, if you will, because there's other things that kind of get in the way and then they need additional deliberate practice for. So if you're to take the multiplication times triple checks, which were just completed last week, you do need to dedicate some class time to allow them to have the deliberate practice necessary. So that something else has to give way. And that sometimes is the number talks. And that is something we're okay with because we know up until that point, they've had a pretty steady diet of it.
yeah.
So they're not, we can drop into any class and get into a number talks, and the kids would know exactly what to do in terms of the rules, even if they've missed it for a month.
It sounds fantastic, Omar, and yeah, I'd like to see it at some point. Next time I'm in London, I'm going to drop in on you and see if I can see a number talk session, because it sounds fantastic.
We are going to be doing some number talk tours next year, actually.
So we know what number talks are now, and how they're being used to great effect by the sounds of it at Nightingale. We've just had a quick conversation to say that I'm going to invite Omar back on actually to talk about some of the ed tech side of things, because I know that's something else that you're doing really well at Nightingale. But I think we'll just focus on number talks for this episode because it's fascinating. For listeners who are thinking this sounds like something that they might want to introduce in their schools, where Oracy might be a focus or something they'd like to develop further, it might be useful to understand the pitfalls and the trials and tribulations that you might have taken to get to this stage, because as we were saying earlier, implementing any sort of change is never necessarily straightforward in education. So it'd be really interesting, Omar, if you could just give me a little bit of background as to how you ended up at this stage.
Yeah, I think when we really looked at how we're going to approach maths differently at the school is when I was introduced to John Hattie and his work. John Hattie, I'm sure you guys are familiar with, has done lots of, I think he's got 11 books, 12 books and counting, could be many more. He introduced an approach called visible learning. And he had visible learning for English, visible learning for maths. And what it is he takes meta-analysis and he identifies, along with his team, some of the best strategies that you can use pedagogically to use within schools. So sometimes those things go really well and they're simple to introduce and be consistent about, and sometimes they're a little bit harder to unpick. But when we looked at visible learning for maths at our school, the key thing that we took away was matching strategies to the learning of the phase. So going from surface to deep and transference models. So that idea that you've got surface level understanding, and this is where the ed tech, we can talk about it next time, came in and played a much better role for us, because it allowed it to be deep learning and allowed them to transfer. And we could see that in real time. One of the other aspects that really helped us was, going back to your point about Oracy, it suggested that mathematical talk to promote reasoning and discussion would be a massive gain for us. So we were trying to put in structures to allow that to be successful. At which point we fell into another book, which is Designing Group Work by Elizabeth Cohen, and that is based on heterogeneous working groups. Are you familiar with the book? I see you smiling. Are you familiar with the book?
Yeah, no, I'm smiling. It's just so great to hear research put into practice in a school, because it can, I know from experience, it can be so difficult. You are spinning so many plates as a head teacher, as a teacher generally, that it sometimes feels like, and this is something I talk on a little bit, is sustainable change and how you can effect meaningful change in schools. And I know that for a lot of people, it feels like there's a need to change things quickly and to quickly implement change and things. And sometimes that means trying to find a solution. It was interesting when you mentioned earlier about introducing the scheme of work into school and thinking that this is it, this is the fix, everything could be great after this point. And actually that's just one little part of the puzzle. So it's just so great to hear all these different pieces of research and all the effort I know it was a lot of effort, but all the work that went into trying to find the best way forward, and how that was a process that needed to occur over time, and is still a work in progress, I'm sure, judging by your approach to things. But I was smiling because, it's just great to hear all these different bits of research, some of which I'm familiar with, some of which I will go away and make myself more familiar with. But a lovely way of building research into practice.
Yeah, for us it was I wouldn't say the seminal book, but it was definitely the book that kind of gave us that assigning competency within group work, because it followed a Singaporean approach, which at around 2017 they were the top within the piece of results. So everybody was trying to figure out what is it they were doing that was going so well. And I listened to one of their speakers, and they talked about assigning roles within the groups of four. We were flirting with the idea of using Kagan structures, and then in 2018 we introduced it properly, and it really took hold. So the role aspect of making sure that everybody was held to account was what we took away from that book. Everybody has to contribute, and we did this thing called Math Mastery class, where kids were going back to the idea of actually presenting themselves. We're given worthy questions, and worthy questions came for me from Jo Boiler and her book, and she was talking to us about this in something called the Railside Project. I'm pretty sure is the name of the title of it, where you're giving them a task that isn't just math-based. It's whether they're going to have to work collaboratively to create a culture to get the answer and solution. So it's not a straightforward answer. It's not, it's going to take some work, and it's going to take group effort. And each of those roles, such as a facilitator, recorder, checker, and a manager, had something very specific to do. And quite often played into the strengths or the weaknesses to try to develop that child from a cultural aspect. And that was really useful, which then led to making thinking visible. Which is by a Zero Hardware project that I'm absolutely a massive fan of. Making thinking visible is about using very clear routines to move the needle. And what we wanted to do was, again, how do you, and I know there's if you listen to John Hattie's work in a discussion, a book called The Purpose of Education, there's a lot of discussion around, can you actually make learning visible, because it's a process. And I found that really powerful, and we found that to be right. That's going to be our entry point. So they have a couple of routines, which is like see, think, wonder. But the one we used a lot was what makes you say that, because you can never really answer that question. You're kind of always pushing them to come back and be more, to offer more justification for whatever reasoning they're doing with. So that was really powerful for us. What I used to think, and now I think I'll go back to 3 squared. I used to think it was 3 times 2, and now I think it's 3 times 3. So so putting that frame into it, massive changer for us. It's just little tweaks where we were taking different concepts and but of the same ilk, where we were trying to implement them. And then we went to, like I said, we had Kagan structures, and Rally Coach is something that we found really powerful. So, literally it's like having another child coach another child's hand through what they're supposed to do with a particular question. And that process of being able to articulate what it is that they need to actually complete, particularly when you're doing a math question, so powerful. So like all of those things came into, how do you do number talks, to go back to the point? How do you do number talks with all of the things that we want to embed as our approach to our pedagogy teaching? And that's why it's gotten better, and it's constantly involved. So it's never gone through a year where we don't think about it differently, or there's something new, or sometimes something's fallen off. So we are going back, we call it gone back to basics for some of our Kagan structures, because like I said, 2018, we've been doing it for quite some time. And as you can imagine, there's some new people that have come into the school, some people have left. And going back to the basics was making sure that we're using some of those key strategies within Kagan effectively to make sure we're bolstering all of the learning that we're doing at the school, specifically that which requires any structured conversation. Oracy is something I'm a massive fan of, and I know it's something that our kids need. And we've introduced something called Dr. Doctor this year. So within writing at our school, As you can imagine, I mentioned earlier, EIL is one of the key things that we're working on, and writing is one of those areas where we recognize our children don't have an opportunity to speak about or say what they're going to write a lot. And this will get us right back to number talk, so just be
Yeah,
patient.
that's okay. No, that's all right.
The doctor model is where you discuss, you rehearse, you draft, and you redraft a piece of writing. What we've recognized is that simple model is something that we're going to be able to dump into all of our aspects of learning, because it'll slow down their thinking process and give them the clarity needed to actually complete just about anything. So we're going to be doing that in some of our math lessons as well, particularly within number talks. Discuss the topic. Quite often when we do our number talks, it's in silo. It's when children share that you start to going, if a misconception comes up, which we hope that it does, you get to unpick it and reteach what the concept should look like, pushing them to our always method. But the doctor is going to be that slip in that we're going to be able to say, okay, now I want you to discuss the question with the child. I want you to draft, but we're going to do it with rally coaching. And it's constantly layering how you're going to actually go through that lesson in a very succinct way. And then after you've done your redraft, you say, okay, I want to check the redraft to check your answer to make sure that's correct. So we're already thinking about, right, this is a really great model, had a massive impact. How do we move this over here, and what does it look like in a math lesson? Yeah, that verbal discourse that we are encouraging a lot at our school is the thing that has made a massive difference.
I love that, Omar. It sounds fantastic, and as I say, just really impressed with the thought that goes into the implementation of these different approaches, and the teachers' toolkit that you are developing together as a school. It sounds wonderful. There are so many other things that I would love to talk to you about, but we're just short on time. We're recording this, would you believe, on a Monday morning. So Omar's in school. He's got his office door shut. I'm sure there's probably a queue on the other side of it, if I know anything about head teachers and how their day goes. But Omar, just briefly looking ahead, what are you working on next? I know you mentioned that doctor approach and the Oracy side of things. Is there anything else on the horizon that you're involved in?
Yes, there is a couple of things that are on the horizon. As I think I mentioned earlier, the idea that I'm going to be working with the NCTM within a different capacity, and that is going to, it's going to be amazing because it's on Oracy, and I really want to just make sure that I'm getting out there next year looking for schools that are actually doing mathematical Oracy in a really effective manner. So I think us coming together has been wonderful because I only met you on LinkedIn, and I think it's a really great forum to actually get in touch with other schools. And for me, it's one of those things where I'd love to know schools within the London area or greater where they're doing Oracy or doing math in a very innovative way, because I'd love to see it.
And I'll share, if that's okay with you, I'll share your LinkedIn
Yeah, absolutely.
link, if you like, so that people can get in touch with you if needs be. You've also got something coming up with Impact Ed, is that right?
So Impact Ed are running a research project with year 6 classes, and they're basically looking at a particular platform called iExcel, which we use quite a bit at our school to support with. It's a digital adaptive platform to see if it has the impact desired to move the needle, if you will, particularly for children in year 6. So we're looking for schools in year 6 cohorts that have access or sufficient access to technology to complete about 40 minutes of iExcel usage per week. It's really simple in terms of the trial. You just have to do an iExcel diagnostic at the beginning and iExcel diagnostic at the end of the trial. And if you are a part of the schools that are going to be in the random control trial, we're going to try to complete 40 minutes of using iExcel per week. As a school, we have completely integrated the use of iExcel into our guided practice and deliberate practice elements of our lesson. It's not something that sort of sits on the side. It can, and that's how we initially introduced, and we'll probably go through that in a lot more detail the next time that we meet, Jon.
That sounds fantastic. And as you say, I'm really interested in finding out more about that. And we'll definitely be having another conversation about the EdTech side of things and how that fits into maths lessons, because I think it's an area that lots of schools struggle with. It'd be great to hear a success story. And then we're just going to wrap things up, Omar, if that's okay, with a quick fire round.
Okay, I'm nervous.
So there's nothing too tricky. Favorite number and why, if you have one?
Oh. Okay, favorite number is 4. I think it's my favorite number for no other reason than when I was a kid. It was a number I wore I'm a massive basketball fan. And yeah, it was a number I always wore. For no other reason than that, just my favorite number.
Yeah, no, I'm on the same. Mine's 3, and I can come up with lots of reasons why 3 is a great number, but essentially it boils down to because that's what number was on my shirt when I play football. Favorite. Oh, we could be here all day with this one, Omar, knowing you already. But favorite maths tool or resource that you're currently using? Yeah.
Okay, yeah. I'm learning a lot about Polypad, and I feel like I've just scratched the surface. It's a free at the point of use representation platform that allows you to pull in lots of different tools, whether it be Dean's, 3D shapes, 10 frames, and there's an interactive nature of using it on the screen. Kids in your reception use it, kids in year 6 use it to show their thinking with regards to maths.
Fantastic. And then last question, is there something that used to be a hill that you'd be willing to die on in maths education, something you believe strongly about, but now find yourself walking back down or changing your mind about?
Yeah, that there was a right way to do things. I think there's lots of right ways to do things depending on your audience. And I think that's the key thing that I've definitely learned. We're a school that has to do a lot more overlearning than maybe the average. Because of the nature of where our children are coming from and their starting points. But that doesn't necessarily mean that's perfect for another school. And that's necessary for another school. So I think the hill I would have died on in the past. It's no, you have to do math mastery. This is exactly how you do math mastery, and you'll have success if you do it this way. Yes, you will have success, but it doesn't mean it's the only way. And what it looks like in one school, I can guarantee you, does not mean it looks the same in another, even though they're using the same banner.
Well, once again, I find myself agreeing with you, Omar, because, working with lots of different schools. Where I am in Derby, I work with lots of very small schools, literally 2 classes in a primary school, and then some very large ones. And there is, I would agree, not necessarily one right way. Lots of great principles, lots of great approaches, and finding the one that works for you and your children and your context and your setting can take time, but is a really valuable search. Thank you so much for everything that you have shared this morning. I know that people have taken a heap from it, and I really appreciate you being so open and sharing your journey in maths teaching and Nightingale Primary's journey in number talks. And we will definitely be catching up again, Omar. It's been absolutely fantastic talking to you. Thank you very much.
Thank you. I appreciate this opportunity. I really do.
Thanks again to Omar for joining us on the podcast. Really interesting to hear what he had to say about how he runs his school and how he weaves Oracy into everything that he does with maths.
Yeah, really interesting interview, Jon. Lots of key takeaways there. And this is the part of the show where we discuss our key takeaways from today's interview that you might want to use in your own school or your own practice.
So what did you take away from that conversation, Becky?
Well, I mean, I've taken a lot away from it, actually, Jon, but I think probably the biggest thing for me, and something which really resonated with me towards the beginning of the interview, was when Omar was talking about his revelation when he started working with the NCTM. And it resonated with me because I had a very similar experience. I think when you've been teaching for 10 plus years, you do start thinking, you're quite good at it by now, you know what you're doing. And I think he really showed the importance of staying open to that change, that you might think you're doing it the right way, But sometimes something comes along or you learn about something new that can completely change your pedagogy. I mean, I thought I was doing a great job, but when I did the teacher research group with my local maths hub, it completely changed the way I looked at not just teaching maths actually, but pedagogy and teaching in general. And so I think it's really important that you don't, I think you often hear things like around CPD where people say, oh, we're just reinventing the wheel, we've been here before. But it isn't, is it? It's an evolution of that. We've learned from before and we've moved ahead. And I think it's really important that educators try to keep that open mind to not necessarily new initiatives, but new initiatives in your setting maybe, and just really thinking about why you should adopt something and why it would be might be a good idea for your practice.
Yeah, absolutely. And the world changes, doesn't it? And, we need to change with it a little bit as well. I also thought it was really interesting along those lines that Omar was very much concerned with making sure that the changes that he was introducing were evidence-based. They weren't just anecdotal, I've heard of a school down the road that's doing this, we should try that. And I know sometimes when I've worked with school improvement teams and things, it can be tempting to want to just have a quick fix for something that we've identified a problem. What's the solution going to be? Well, I know a school that does it this way, so let's try that. But just because it's working in one school over here doesn't necessarily mean it's fit for your school. And obviously Omar's school in particular, he's recognised that they have a real need amongst the EAL population in the school to develop vocabulary and oracy and things. And so he looked for a solution that would do that as well as further develop their math skills. And also recognising that maths is that universal language that children can access and use as well. So, I definitely take that away, that you can. Sometimes there's maybe a feeling that some academic research is just academic, and is difficult to translate into practice. But I think what they're doing at Nightingale School shows that you absolutely can take something that has been shown to work in research conditions and then apply it into school, maybe with appropriate adaptations.
Absolutely. I think what came across was actually you're in it for the long haul, aren't you? You're not going to necessarily see instant results. You're going to have to adapt. You're going to have to change it. He was saying the first year we did this and the second year. I mean, a year is a long time, isn't it, in school? But it really is important not to just take the first set of results and think, okay, let's try something different, but to try to really adapt things to suit your setting. So yeah, definitely took that away too, John.
Yeah, and there can be a pressure, can't there? That you, as you say, a year is a long time. It's a long time in a child's life, and there can be well-intentioned pressure that you want to do the very best you can for the children that you've got in front of you right now. And of course we do. But until you go through the process, you don't necessarily know what the best way forward is, do you? Until you've tried things, adapted them, evaluated them, and then adapted them again, perhaps. So yeah, that ongoing process of improvement in school is definitely evident from Omar's practice, I would say.
Yeah. I also loved how he was talking about the ambitious language that was being used as early as reception, and probably early. He mentioned nursery at one point as well. And I think he used the word exposure. And I think it can never be a bad thing to expose children to ambitious vocabulary, can it? I think sometimes we shy away from it. Oh no, it's not introduced until year 2. We're not going to mention that. But actually, so important that they have exposure to that and hear you modelling it. And it's not always easy. I think you mentioned it in the interview that, for some adults, if they're not familiar with the vocabulary, it can be why would we do this? But it is such a key tool. Vocabulary is such a key tool in empowering children to talk about their maths with clarity, isn't it? So it was lovely to hear about him saying that the language is being used in the early years as well.
Yeah, and again, I'll just reiterate, I know I said this in the interview, but if a child can learn what a split digraph is, then they can learn what an addend is. I think it's often the adults that are less familiar with the language that is actually the barrier. So as a school, if you have a commitment to using that language in everyday maths lessons, then it doesn't become a novelty. It just becomes part of practice. and then hopefully we won't have children in upper key stage 2 who still don't know how to find the product of two numbers or the sum of two numbers. So yeah, absolutely, totally agree there, Becky. That was another key takeaway.
Yeah. And the other thing, which I think is probably fairly embedded in lots of schools in one way or another now, is the CPA approach and how important it is. And I think it's great, but it's not a box ticking exercise, is it? It's really important. I think he sort of talked about the importance of bridging between them. And I think it can be seen as a journey. You know, we go from concrete, then we go to pictorial, then we move on to a more abstract method. But actually, it's not about that. It's about seeing the links between them and using them interchangeably. Actually, you know, I think in some schools you might see a lot of concrete lower down the school or in certain groups of children. It's not about that. It's about building understanding. So I think it's always important, these things that, you know, we talk about a lot, and we could say, yeah, we're doing that because we've got some deans in the corner, or we've got some we've got some place value counters. But it's actually making sure you're doing it with purpose, isn't it? And why are we doing it, and how are we supporting the understanding?
I completely agree. And I think you've hit the nail on the head there when you say the purpose of it. So whenever I'm working with teachers and we're thinking about how we might represent the maths for that lesson, the place that we start with is, what are we trying to get the children to notice here? So how, you know, what do we want them to see? And then what's the correct way to get them to see that? You know, what's the best way to get them to see that? And that could be concrete, could be pictorial, or it could be abstract. And I think the other thing to really bear in mind is sometimes the way, and I think you've alluded to this, but sometimes the way that concrete, pictorial, abstract is presented is that it's that linear. You must always start with the concrete, move on to the pictorial, and then the abstract. But as you say, the abstract is not a higher thinking order than concrete is, because I could teach somebody to do something very procedurally and they'd be able to do it. But if they can't then show me that using concrete resources, then how well do they really understand it? So if you are interested in developing depth of understanding and depth of conceptual knowledge, then I would absolutely urge you to make sure that those representations are a key part of any maths lesson.
Yeah, definitely. And the other way around, you know, if you're tasked with a problem, particularly maybe a worded problem or a very abstract problem, one very key strategy you can use is create a model or an image to support that, isn't it? So if you don't have an understanding of how that all links together, that will be a very difficult thing to do. But lots of very complicated problems, you might, even very able mathematicians, you start jotting things, or I would start jotting things down or drawing things. I'm not necessarily an able mathematician, John, just to put that in there. But you would start, you would create something as a model for it. And I think if you don't have an understanding of how that fits together, that would be very hard.
Okay, now it's time for us to share our resource of the week. And what fantastic Twinkle resource have you gone for this week, Becky?
Well, John, as we've been talking about theme parks in the Maths of Life section today, I thought it would be the perfect time to share our theme park project pack. It is designed specifically for year 6. It's that time of year, isn't it, where all year 6 teachers are trying to keep maths meaningful and keep it going really in between assembly practices and productions and levers things. So the project pack it's a combination of maths and English actually. So it includes a little bit of persuasive writing, but also some statistics, budgeting, percentages, all around the children designing their own theme park. So that's our resource for this week.
And I can personally vouch for that resource, because I have used that at least 5 or 6 times in the last 5 or 6 years for different classes. And the reason I kept using it was because it was so popular. The children loved engaging with it. It fitted into our theme park topic. And yeah, there's just lots of different aspects to it that you can do, as you say, over a week, over a couple of weeks, depending on what time you've got, what time you can dedicate to it. But it really, really engages the children, and a lot of the thinking is done for you, which at this time of the year is always welcome, I think. Well, that's about it for this episode. Thank you for listening.
If you've enjoyed the show today, please do share it with a colleague. You can also leave us a rating or a review. It really helps new listeners to find the podcast.
And if you are planning your next staff meeting or briefing, or this time of year, Inset Day. Don't forget to download the companion PDF for this episode from the Twinkle website. Just search Primary Maths Podcast on the site and you'll find it there, alongside links to CPD videos and all the resources that we mentioned.
And on the podcast next week, Jon is speaking to Kate Frood, former head teacher who taught maths throughout her headship and has a real passion for problem solving.
Yeah, I'm looking forward to that one. That's next Tuesday on the Primary Maths Podcast.
Until then, thank you for listening and have a great week in school.
See you next time.